Hello everybody, welcome back. In this video series I want to start working on this Heathkit HW101 and its power supply. I hope to get it back up to new working order. I bought this several years ago and it had been refurbished, I believe, at that time. But since then it has collected dust. When I first got it, I worked, I know it would send and receive Morse code, and so I never did really try it on voice. But since then it is set and gotten dirty, and so it and the power supply, I think we probably need to at least replace the capacitors in it. And I want to go through, do the boards, and alignment, and get it back up to 100% and put it on the air and actually start using some of this vintage gear. Now this was popular back in the 80s. It was kit form. You'll find varying degrees of them, how they were put together, and it has a lot to do with the builder. But we'll start with the power supply and replace the caps and get it up to snuff. Let's look under the hood here. I've already got the screws out of it, and we'll it's cosmetically it's in pretty good shape. A little dirt, but let's look under the hood. Okay, this uses 20 tubes. There's two 6146 Bravo final tubes, and these boards are modular. Each board does a different function, so you can troubleshoot and repair each board separately. That is broken, which that's an O-ring. I'm not sure what the original drive belt was, if it was string like this one or if it was actually a O-ring. So we can look and replace it either way. Of course, like I said, this one used, I've used it on CW. Let's see if I can get under here without tearing it all up. This is the underside. It's got both the single sideband and the CW filter. So that'll be handy when you work in CW. It's fairly clean under here, and the soldering looks pretty good. So hopefully we can restore and bring this up and get it on the air and actually use it. Okay, a quick view of the top boards. There's some more underneath that we'll have to get to a little later. It's the modulator board here. This is the IF board. This is the bandpass board, the audio board, and the RF driver board, which goes into the final. Of course, this is the oscillator. The board will be in there, and the tuning condenser will be in there. So there's a brief overview of it. So let's go and look inside the power supply and see what we've got up against. We want to get a good power supply before we do anything to this, so that's where we're going to start. Okay, let's take a look at the power supply. This is the Heathkit power supply PS23. This came out in about 1983, and it has the same schematic as the HP23C. So and it ended in 83, so I figured this is the last one. Now you'll notice there's not an on-off switch, there's not a bias adjustment, it's got to reset. We've got the schematic, and I've got a copy of the manual, and so we'll go through it and look at it a little bit. There's the inside bottom layout of it, and should have a schematic right here. And this utilizes, well, I'll just read you the description a little bit. It's designed to provide all the necessary operating voltages for fixed station operations of the Heathkit amateur radio transceivers. The versatility and many features of this power supply make it ideal for use with other types of amateur radio equipment. So you can use this on I've seen this used on Collins and probably Yaesus. It features a high voltage source and a choice of 2 low voltage sources, a fixed bias source and 12.6 volt filament source. The filtering and good regulation provides for the DC sources. The power transformer has a dual power winding, so you can wire it for 120 or 240. A series connection is provided to the AC plug, so that when you turn the transceiver on, it works the power supply. All the output voltage connections from the power supply are made through the power socket, and it has a cable that came with the radio. So let's get in it and take a look at it. Okay, we'll take these off. Looks like a little dust on here, maybe a little rust. Repaint the transformer. You can buy transformer kits, or I'm sorry, capacitor kits for this, and to get them rebuilt in those cans and a board for it to go on is quite a bit of money. So anyway, these are 125 microfarad at 500 volts. I bought some 150 microfarad at 500 volts, and they will probably go inside that can. So I could probably either mount those there or put them back in the can. I don't know. I hadn't decided what I want to do yet. Anyway, the circuit itself, while I've got this, I went ahead and bought the bleeder resistors just in case. Also, I went ahead and bought a capacitor rebuild kit for the HW101. So we've got that when we get ready to do the transceiver. Let's look under the bottom real quick. Look like a screw missing there, which that's probably not too big a deal. Another screw missing. So, but this serial number is 922, so I would just wonder how many of those they made back in 1983 or so. That was the only year apparently they made these, according to the website. So anyway, let's take a look in here. Looks like these are modern capacitors, but I've got replacements for those also. You got your bleeder resistors here, there. Of course, here's your 4 capacitors, transformer. It looks pretty clean in here. It really does. So make sure I get you guys on camera. So the circuit, the high voltage is the winding is 282 volts, and it goes into a full wave rectifier, which is made up of these diodes. And then you've got your capacitor C1 and C2, and so that during one half of the cycle C2 becomes charged, and during the next cycle, half of the cycle, C1 is charged. So that it creates a voltage doubler there. So it ends up getting close to 800 volts on that side before it's over. And then the low voltage circuit, it has this D5 and D6 over here, and the capacitors 3 and 4, it has a voltage doubler also, and so it creates the close to 300 volt and then the bias voltage is obtained from a low tap on the low voltage line, and there's about 95 volts, and then it goes through D7, I believe, which is here, and goes through R7 and provides negative 130 volts. So it's a fixed bias. I'll test these resistors, and if they're good, we won't change them. I think they're fine. But capacitors, we'll end up changing those, and we may or may not restuff these cans. We'll see. We'll see. But pretty tight space under there, so we'll have to go through it and test all the components and make sure it's up to snuff. And because we want a good power supply before we get onto the transceiver. All right, I think we got a plan of action. I was going to show you something here. We'll clip onto these bleeder resistors and try to check them. And as you can see, because they're in circuit with the capacitors, you're not going to get an accurate reading. You know, in a lot of the other circuits we've dealt with, they you can check them to some degree, but with the capacitors charging and discharging, you're not going to get an accurate reading. So we'll have to disconnect those. So what we're going to do here, to see if we can rebuild those capacitor cans, this particular one, I believe this is number 4, C4. There's 2 screws holding it and 1, 2 solder connections. So we can take those loose and those screws and we should be able to get that one out, and we can see if we can rebuild that can. Otherwise, if you'll look at all the connections we have to do up in here, these 2 would be, you know, to be able to get those out pretty quick, and we can see if we can rebuild it, or we're going to have to come up with some other way of or just putting the capacitors in just like they are. I mean, yeah, they're short. It's not going to be original looking, but you know, it's under the hood, and as long as it functions properly, it's a repair. It's not really a restoration. This is a repair. So, you know, why am I restuffing the can? I don't know. It just seems like the right thing to do. So let's disconnect this and get that capacitor out. Got this disconnected. I went ahead and checked those diodes. Got the capacitor out. That is the part number, the Heathkit part number. So either this is the original, or they were able to get the parts. So I'm not sure how we're going to get this. I've seen people take a Dremel tool and cut it here and then put it back together. We'll see how this works. Alright, I failed to document this on video, but I'll have another one I can show you over here. I decided not to rebuild this simply because I saw some methods of it, and they took and cut this, and it looked kind of ragged on the bottom. So what I decided to do is I pulled the grounding strap. As you know, this went through a piece of metal. Let's see if I can show you on the other side. As you can see there, this is a grounding strap that this capacitor went through and soldered to and was fastened to, and it held it to the chassis. But these 2 capacitors are grounded to chassis ground. These 2 are above ground because it's part of the voltage doubling circuit. So let's look under here and see what we've got. What I just showed you. Let's zoom in a little bit. I have not put the components back in yet, but what I did is I pulled that out, the capacitor out, and then I took and made some phenolic boards the same shape as that bracket. And what I did is I took and I drilled a couple of holes in it, and I mounted the capacitor through here, and I put an eyelet here, soldered it to the positive. The negative, I came over here and put it on the ground itself. Now I'll go back and I'll put the this diode to ground and these two terminals to the positive. The only reason I used a phenolic is to glue, to have a surface to glue the capacitor onto. Now when I get over to here, I plan on just gluing the capacitors to this phenolic board that's already there and replacing it. So when I get the other capacitor out, I will show you how I put it back in. Starting to disassemble the other capacitor, lifted a leg of the 100K resistor, bleeder resistor. As you can see, it's a 122K, which is 19% out of tolerance. It's a 10% resistor. So I've got the resistor, so I'll probably change that one. And if that one's bad, I expect, now would this work? It probably work fine, but since I'm here, I'll just replace it. Got that out. Check these three resistors, which we already checked that one. But these two, one was in, one was out. One was out 13%, the other one was out, well, it wasn't out, it was like within 8%. So since, like I say, since we're all here, just change them all out. I've got new ones. So, but I got the capacitor out, and you can see the plate. Got to do some desoldering there, and we'll fix this one up, and I'll show you how I fix the other one up. I've got that. Of course, there's the negative side of the capacitor. Here's how we're going to do this. We're going to go ahead and put that in there like that, and then we're going to put that on there like that. Of course, we will go ahead, and this is the positive. We will solder an eyelet on there for connections. And now this one really doesn't matter at this point, but what we'll do is we'll take and we'll put glue here, and then we will glue the phenolic board to the capacitor centered up, and then put that on there and solder it, and then we will mount it that way. Now we'll end up either putting a tab here and here for the resistors, or just tack it to this. This is a good surface. I've soldered several things to these rings, and it's not a problem soldering to it, so we can do that. It's not an issue. But that's how this goes together, and we will glue that on the top of that phenolic board. I've removed the other one, and I left all the components on it, so I'll know where they go. And remember, we're going to take this one off and glue another one back on it. And then we can build it back like that and put it in. This is all part of that voltage doubler on the right here's where you get the 800 volts coming off of that terminal there. I toyed around with how to make a grounding strap for this this capacitor. Now I've glued this in. What I ended up doing was cutting the very end off of the old capacitor, and putting it through the slots, and then gluing the capacitor in place. Now what I will do is I'll come back here with the negative and tie it to here or to here, one of the two, to make sure that that's grounded. And then of course I'll put an eyelet on that one. What I do is I pull the insulation off the eyelet and just put it on there, and that gives it a place to solder. And so I did end up cutting the end out of the capacitors. I took and then I painted them black so that it wouldn't stick out like a sore thumb. So I think that's going to work out okay. What do you think? Just a comment. The cement I use is the Quick Grip Contact all-purpose permanent adhesive, and it is very quick dry. Made by Beacon, perhaps, but it sets fast and holds pretty good. Okay, I've got this capacitor in. It looks kind of funny because of the glue right there, but I'll put that there to make sure it held. I've got the resistors put in. I've got the jumper, the blue jumper. I replaced the wire. It was kind of gray looking, but the wire was kind of ratty looking, so I changed it out with blue, which is what it's called for. The ground here. So I think I've got all that with the diode. I checked the diode while I was out. So the only thing left is to replace this one, and this one should be fairly easy. Let's look at the top. Okay, that's what it's going to look like. You can see I put the little black, painted that black so it doesn't look so odd. So they're going to be short capacitors instead of the tall one. But got to change that last one. Then a couple of 3 more capacitors, resistors, and I think we're ready to test it then. Okay, I've got everything replaced. I kind of overkilled it on this. These were like 40 at 150 volts, and all I had was 450 volts, 47s at 450. But they were in stock, so I felt like that's going to be okay. The other is a 47 at 450, and I believe that's what the other one was. Let's see. 40 at 450, so I think we're okay there. Now these resistors, I checked those were well within 10%, so I left those alone. The only thing, I think this looks pretty good, except for it kind of looks like the glue. But it's underneath, shouldn't be that big a deal. I'll go through here and make sure the wiring is correct. I'll just go through the manual and make sure it's wired correctly. Let's flip it up and see what it looks like on top. Okay, there it is. I've cleaned this up. I think gonna take and put a little navel jelly on that, and then probably touch that up, and probably touch this up, maybe put a little silver on that. But we're going to test it first. But there's what it looks like. Instead of the tall capacitors, we got the short capacitors. So it's not original, but hopefully it'll perform, and that's the important thing. This is a repair, this is not a restoration. Okay, I have completed that, and there is a initial test where you take an ohm meter and check the socket, and this is a go no go. If you don't get those readings, then you need to go do some troubleshooting. Well, I did the checks. They looked good, so I went ahead and fired it up. And so since you've seen that, I'm gonna flip it down and let you see the socket, and then we'll do some voltage checks on it. All right, not used to using the analog meter. It's been a while, so care must be taken. We're used to these automatic digital meters that are forgiving, but these old ones are not very forgiving. I've got it set on 25 volts AC, and we're going to check the filament So here's the filament common, and we'll be reading this top scale here, and we'll go to our 12 volts, and we are looking at right at 14 volts unloaded. Now I've got this jumper in. This jumper is on the cord, goes to the HW101 to the power switch. So let's go to the high volts. Let's go to DC, switch down to 1000. Now we've got to change to the 1000 volt plug or socket. We'll go to the ground, which is here, and we'll go to the high voltage, and we're on the 1000, which is this where it shows 10 just above the red there. So let's go to the high voltage, which is here, and we're reading 800, 10, 20, 820. The specs calls 820 unloaded, and that's what we've got. Now let's go down to the 500 volt scale, which is the same position, but we'll move this, and we'll go to the low volt, and let's see, let me make sure I get my numbers right. Should have had this lined up, guys. A lot of times you try to go from memory, it doesn't help. Okay, that was 820 volts with no load, and 700 volts with 250 milliamps, but that was unloaded. All right, so we're looking for anywhere from 300 to 350. We're on the 500 scale in the 500 slot. We'll go to the low volts. So we're on the 5, so that's the middle scale, metal black scale. And that would be 310, 20, 30, 40, 50, 60, 370. So we're a little bit high on that, but I don't think we're in bad shape there. Now we've got a negative 130 bias voltage, which should be in this pin right here. So we're going to switch the DC to negative, and then we're just going to check it there, and we should have let's go to the 250. I think we'll go right here is 250 volts, so we'll go right here, and that should be the top scale, 250. And so we're looking at, there's 100, 150, now there's 150, so there's 125, so it's about 140 volts negative. So that's, I think we're good on our power supply. I'm going to dress up the transformers, paint those two, put it in the case, and then we'll call this good. Alrighty, I took this down to the shop, touched up the, removed the rust off of the transformers, and touched that up with a little flat black, and then I used some chrome brush on paint. Just to keep it from rusting again. Really not, it's not going to be seen, it's under a cover. So now let's put the cover back on it, and we'll be ready to start on the other. I was coming back from the shop with the power supply, and look what I found. I live near the lake, and they come up, and I live pretty good ways from the lake, but they come up and lay in my yard. As you can see, these are 1/2-inch squares, so he's fairly small. But I have found these in my pool, and they get lost. He was out in the middle of my yard. It's a wonder I saw him. I'm going to take him to the lake because it's a long, long way, and it's a treacherous journey for him. So I'm going to take him to the lake here in a minute. But I thought you guys may like to see him. Say hello. Okay, there it is. That'll end this episode, and then we will start cleaning up and testing and evaluating the HW101. I hadn't decided whether to go ahead and power it up. It was working several years ago, so we may go ahead, since we've got the power supply redone, go ahead and power up the HW101 and just see what it'll do. But anyway, I appreciate it. I know this is a little different than what I've been used to doing, but I've been wanting to put this HW101 back on the air and use it, actually use it on the air. Start using some of the vintage gear that I do have, and I've got a lot more that needs to be refurbished, so you may see some more in the future. So anyway, thanks for my new subscribers. I appreciate the old subscribers that's hung in with me for the long delay, but hopefully I'm back for a little while. So from Larry from the hills of Tennessee, thanks for watching.